Preston, I know some molecules are polar and other molecules aren't polar, but those are all pretty small. What if you had a mega molecule? Could it have polar sections and non-polar sections? Oh my god, you're right. Let's make a mega molecule. Ta-da, here is the mega molecule. So we have this whole section over here. It's like, wow, I traveled so far away from the middle, and this is all just non-polar emulsified bullshit on this end. But then over here, we have this big charge and these huge, big negative things, these oxygens. So this is pretty polar. So wait, a part of me is non-polar, but a part of me is polar. So it's like, I belong in the dance over here, and I belong in the dance over here. What is there to do? It's like I'm stuck in the middle. Stuck in the middle with you. This guy doesn't want to mix with this guy because he's like, well, this is the polar section, and I'm drawn to him. And this is not non-polar section, and I'm also, part of me wants to go with him. And these two sides, they're mixing like oil and water. You see what I did there? It's pretty good. Because this is literally water, and this is literally oil. And so if we want to get water to drag oil with it, we need things with big non-polar ends. This is the fundamental principle of soap. That's all soap is. It's just a big molecule that has a polar end and a non-polar end. That's it. It's really, chemistry is not hard. New scenario. You are stuck in a solution. Just a bunch of water everywhere. So this is all H2O. Here's just a little water. I'm hanging on the water. What if I wanted to hoard a section to myself? I wanted to mark my territory. I want to make a gate. No one in or out. I'm making a wall. How would I make a wall to keep water out and water in? Because we're stuck in water the whole time. Let's try what we did before. So let's put all the water in here in the middle, and we got all the water out here, and let's just line them up, stack everything, build a perfect wall out of those polar, non-polar molecules. So here, let's examine what the wall's like. So the outside of the wall, polar, facing out, is gonna mix in with the water, and the inside of the wall is gonna be non-polar, so it'll all stick together. Oh shit. If there's water in the inside, that's polar. Fuck. That's gonna make it all unstable. We can't have the polar and non-polar mixing. It's probably just gonna cause it all to disperse. And that's what would happen. This whole thing would just go out like that. We need to find a way to stick this together. Wait, I've got it. What if we make another polar facing end on the inside? And then the non-polar ends can face each other. Ta-da! So now it looks like this. And let's look at what the wall looks like actually now. We have this molecule facing outside, polar, water out here. This molecule facing outside, polar, water's out here. In the middle, non-polar's meshing and hanging out. It's looking pretty good because the non-polar parts, they're going to stick to each other kind of like glue. That emulsified substance is going to repel everything else around it. And the outside, it's going to float okay in the water. These guys got to stick together, and they're going to. Makes it really sticky because they like this emulsified nothingness goop. It's like an electron orgy in here. Well, meanwhile, out here, we got all these polar molecules seeing the oxygen. Front-facing oxygen boys like to hang out with water. Gentlemen, we have just created, and ladies if you're watching, the bilipid layer. This is the basis of a cell wall. The only difference between what I've drawn in life is that life uses phosphate because phosphate's really freaking good at holding on to oxygen. So it's just a lot better at hanging out with the polar stuff. But outside that, it's basically the same. I don't know what to tell you. Welcome. We have a cell.